Hello everyone and welcome back to the third video of Mastering NPM and Node.js. In this video we're going to be talking about some best practices when starting your project in Node.js. My name is Nicola and you can find my GitHub at github.com/nickfv. My first best practice recommendation is using Visual Studio Code as your code editor for your project. Visual Studio Code is maintained by Microsoft. It's open source, free to download, and probably one of the most popular code editors out there because it integrates so well with many different languages. In the terminal, I'll type npm init-y to initialize my npm project, and the -y flag will skip all of the dialogue. So that'll create this file called package.json, which is at the base of the project, and it's got some information about the name, version, description, and so on. Before writing any code, I also recommend starting a Git repository in the same directory with git init. You can see it initialized an empty Git repository here. And if I do ls-a to show all, you can see it created a hidden directory .git. Also in Visual Studio Code, you can see the package.json is now green with a U that shows that it's an untracked file. So if we want to track it into the history of Git, all we have to do is add it. So you do git add, and then the file name, package.json, enter, and now that U turned into an A. So you can see it says index added. So if I want to commit that, I can say git commit and give it a message. I'll say initialize project. And there we go. We've just made our first commit. So something that you'll probably be doing when developing your Node.js project is installing dependencies. So to do that, you run the command npm I and then the dependency name. I'll use one of mine called smath as an example. So what you could do is you could just run this command as is, which will try to install the latest version by default. Or you could give it an @ and then the version number if you wanted a specific version. Or you can do @latest. And this is good to use if you have versions cached locally. So I'm going to use @latest, which will just install the latest version. But once that's done, you can see it added some new lines here in package.json. And since I've tracked these in Git, again, that integrates very well with Visual Studio. So these blue lines show what's been changed. So we can see that it added these 3 lines and then it added a comma here. Also, by installing that file, it created 2 new files here. We have package.json that just has some more information about each of your dependencies, and this folder called node modules, which actually contains the source code for all of your dependencies. So since I've made some changes with my project, I want to add that as a commit in the Git history. But before I do that, I want to make sure I avoid committing node modules. So to do that, I'm going to create a new file called gitignore. And as I do that, it'll create this file here, which is essentially just a list of files that you want to ignore from Git. So all I have to do is type node_modules. And when I save that, you can see that node modules is now grayed out. So it's not going to be tracked. So what I could do is I could do git add, and then period, which will add everything in this base directory, enter, and now if I go to the source control tab here, you can see that all 3 of these files are staged. So I'm going to go ahead and do git commit, so install smath, enter, and now we can see everything's up to date. So now that I have a couple commits done, I can see the history by doing git log, and then 1 line to make it simpler. So we can see my first commit, initialize project, and now my second commit here, install smath. So if I want to switch back to my first commit, what I could do is I could copy this number, which is called the commit hash. I can check it out. I can do git checkout and then paste that number there, press enter, and now you can see my package.json is back to its original state. If I want to go back to normal, I can just copy this one here, git checkout that one, and now we're back up to date. So that's good if you just want to switch back and forth and see different versions of your code. My next recommendation is creating a clean script, which is something that I like to run before doing an install, so I can do a clean install. So to add a script, I'm going to add it in the scripts object here in package.json. I'm going to call it clean, and you can put any script you want in there. So what I like to do is just remove node modules and package.json. So when I run this script with npm run clean, watch my file structure over here. Now package.json and node modules are both removed. But what I can do now is I can run the install script, npm I, which will just install all of my dependencies back, just as they were. And that's using this dependency list right here. So since I've made some changes again, I'm going to do another commit. And the next step before writing any code is to set up a project directory structure. And what I mean by that is where you want your source code to live. So you could have all your files saved in here, or you could create a subdirectory, or do something else entirely. So the next thing to decide on is how you want your project structure to look like. And by that I mean, do you want to save all your files in here, or save it in a subfolder, or do something else? So a main pattern that I've noticed is saving all of your source code files in a subfolder called src, and then test files in a test folder, and then build files in a dist folder. So what I'm going to do is I'll create the source file right here, and this is where I'm going to save all of my code. And so another thing I need to decide on before writing any code is what language I actually want to be using for this project. And so there's two options here. I could use JavaScript or TypeScript. So actually there's only one option. So if I want to install TypeScript, it's the same command as I use to install SMAF, except there's one small change. If you notice, I have this -d flag here. And when I run that, it'll actually install TypeScript as a dev dependency instead of a regular dependency. So what that means is that what I'm going to do locally is I will build and test my project, and then when it's ready to publish, I will compile it, and that'll compile the TypeScript to JavaScript, and this dev dependency is no longer required. So anyone else that installs this project will only need to install the dependencies in this list right here. So now I have dev dependencies. So I'm going to just run a clean install, npm clean, npm just to do a clean install there. And now we can actually start writing code. So I'm going to go ahead in my source file, I'll create index.ts. And we'll just do a simple hello world. So here I've created my TypeScript file. So what we want to do is compile this to JavaScript. And since we've installed the TypeScript dependency, we now have access to the TypeScript compiler. So I'm going to add a new script in here called build. So in my build script, I call the TypeScript compiler called tsc. I pass in the input file, which is source index.ts, and I also give it an output directory, which I call dist. So let's see what happens if I run this script. So you can see it created a new folder here called dist, and if I open that up, it has index.js this time, which has hello world from TypeScript, which is the same file as here, so it's not very interesting. But I'll do an example later that actually compiles. So anyway, now that we've built it, we want a run command. So I'm going to create a new command called start. And to start the program, I'm going to just call node and then dist/index.js. So when I run npm run start, then we get the hello world from Typescript. So one other recommendation here is that we don't want to commit our dist folder. So I'm going to add that to ignore. Also, I like to add that into the clean script. So when I want to do a clean, I clean out fully all of the build files, all of the dependencies, everything of that nature. So when I do an install, it's a fully clean install. So when I do npm clean, and then I do an install with npm I, and then I can do a build with npm run build. And now I have a fully cleaned up directory structure here. So I'm going to also just do another git commit here, since I've made a bunch of changes that I want to store in the history. One more thing, if you're using TypeScript as your project's language, I recommend creating in the base folder a file called tsconfig. And this file contains all the compiler options for TypeScript. So I'm going to add an example one right here. So what I've done here is I've created tsconfig.json with the outdir of dist and including all the files at source. So when I go back to my package.json script, I can actually get rid of all of the tsc inputs here. So I'm going to run clean again, and then install, and then build it one more time just to prove that it works. And when I open up dist, I get the built file. So this is where you'd put all of your compiler options instead of putting it as command line flags here. So I'm going to do one more git commit. So now that we've created a project structure, we've chosen a language, we've installed dependencies, one thing I'd recommend before getting too deep into the project is creating a project README and a changelog. And so these are two pretty easy files to create and require minimal maintenance. So that's always a nice thing. So here we have an example README and an example changelog. One thing that you want to make sure of when maintaining the changelog is to match the version number here as the version number in package.json. So if you check out something in the Git history, then you're sure that the changelog describes exactly the changes that you've made in that version. So once again, I'm going to go ahead and commit those files. So as promised, I just want to do one slightly more complicated example with TypeScript. I will use one of the functions from my dependency. So here I've created a more complicated TypeScript code, which takes in an array of numbers and it prints out some statistics. So I'm going to build that with npm run build. And then I'm going to run the file, npm start. And then so we get our average, our standard deviation, and our variance. So if I go into dist index, you'll see that actually the code does look different because it didn't successfully compile to pure JavaScript. So that's all I wanted to cover on the project structure. One last thing I wanted as closing notes of this video is to get familiar with npm.js. So right here I'm on npmjs.com. This is the full package directory of all npm packages. You can see there's 2.7 million packages with almost 60 billion downloads in the last week, which is pretty crazy if you think about it. And so you can search for any package here. So I'll just search for SMAF as the example. So if I search for SMAF, you can see it comes up with SMath is the small math function library. I can click on that. It'll take you to the package README page that should have some installation instructions and how to get started, maybe with some examples. And it'll tell you how to install it. And then it might also give you the repository or home page links here. So some things maybe to look out for when deciding what packages to install. I prefer to install packages that have been published in the last year or so, just so that they're actively worked on, because some projects don't get any updates in several years and then have security issues with them. But if you install something that's been updated in the last year, usually it's pretty up to date. Another thing you can look for is the number of downloads. If the number of downloads is pretty stable or if it's increasing, that's usually a good sign. But if you don't see many downloads or if the number of downloads is going down, it might be something to avoid installing that and maybe look for a different package instead that has the same functionality that you're looking for. One thing to also be a little bit, looking into is the number of dependencies that a package has. So SMath actually has 0 dependencies. And you can see this is where DevDependencies comes into play too, because it has a few dependencies to compile and to build it initially. But if you install SMath, it actually does not install anything else. So for example, the D3 package actually has 30 dependencies. So just know that if you install D3 into your project, you're also going to be installing all 30 of these dependencies as well, but none of the dev dependencies. You can also see how many dependents it has. So that means about 5,500 projects are depending on D3. And it seems to have increasing downloads. So this was probably a pretty safe package to install. Also, it's pretty well known. Anyway, just beware of some of these numbers when you're looking to install packages. If it's something silly like is 10,000, let's see. All this package does is tells you if a number is 10,000. That's probably something you could write on your own, so you could avoid installing a package for that. That's all I have for this video. I hope I've shared with you some of my wisdom, and I hope to see you at the next video.